to put down my mic. Is that better now? Okay. Okay, cool. Perfect. So the union is used to union these two columns like this. If you have 1, 2, 3 and 2, 3, 4, it will union this two column into one column like this. 1, 2, 3, 4. And if you have used the intersect, it will return the intersect part between these two columns, like the 2 and 3. You see, these are the common parts. And if you use the minus, it will like use the let me think. If you use like a minus b, it will use the side the column a minus the intersect part between a and b. So in this case, if you use a minus b, it will returns you just a 1 because it will minus the common parts between a and b from the result set a if you use a minus b. And if you use b minus a, then you will result in a result set that contains all the elements from B, but remove the common part between A and B. This is minus. So for example, if we like first exam what contains in the HR employees. So the employee table contains many employee of ID from 100 to maybe I maybe to some employee ID. So to illustrate that, we can select some in the first statement. We can select HR employee from like select the employee. First, select some employee ID within some range. So we can select from where the ID less than 100, like this. Can I do like this? I think maybe I should just write down the whole name. So now I select the employee ID from 100 to 106. And also in the next select statement, I can select employee ID from the HR employee table where maybe this time let's select employee ID from 103 to 100 and 110. So greater than 102 and I'm not sure whether this syntax is correct because it's been a while I didn't write those SQL queries. Maybe I should use and I guess employees. Okay, right. We must use this and keywords to combine those two conditions. Like, so if you run this, you see it will return us the employee ID where the ID from 103 to 110. And you see these two columns have some intersection part from 103, right? So if we use the union to join them together, it will result a result set that do not have duplicates, and also from 100 to 110, right? Just like the example we give previously, like the one A have 1, 2, 3, and B have 2, 3, 4, and if you union them, you will get 1, 2, 3, 4. And if you intersect them, it will returns you the common part. So now let's see. The common part should be 103, 104, and 105, right? So we can see if we use the intersect. You see, this is the common part. And if you use the minus, so the minus, if we use this result side to minus this result side, means it will contains all the elements in this result side, rather besides the common part between these two. So it will only result if we run this A minus this B, it will return us the 100 to 102, right? Because this is all the elements and remove the common part. So this will be the result, 100 to 102. You can see if you use the minus. This is the result. And also, if you use those 3 keywords, I think one common is that this 2 column must, one requirement is that this 2 column must have the same variable type. For example, if we select this ID, I believe should be the type of integer, right? If we select the last name, and I think maybe we can do this. Let me try it first. Yep, we can do it. And if we try to use maybe use the union first, you see, expressions must have the same data type as corresponding expressions. Like they do, maybe they can have, you can merge 2 different columns, but they must have the same data type. Like you can, so this column is last name, right? You can also merge the union, the last name with the first name, because they have the same data type. So they do not need to be the same columns from the same column, but they need to have the same data type. If you run, you see, you can union the last name with the first name column, but they are different columns, but they have the same data type. So must have same data type. This is union, intersect, and minus. So maybe those 2 are quite obvious, but just the minus is maybe needs some explanation. That A minus, like this A is the result side A, like this result side A, result side B, this is, and if you use A minus B, the result should be A minus the intersect between A and B. So this is minus. And any questions related to this syntax? So, okay, if no questions related to this keywords, we can further move to the next syntax called join. So this is also maybe in the front end position, they will ask like what is the difference between left join and right join. In the backend interview, maybe this question not that much commonly seen, but sometimes they will ask you some SQL questions like the difference between left join and right join. So today let's talk about left join, right join, what is full join, what is cross join. So those are 4 types of join syntax, like left join, right join, and also full join, cross join. So this join statement actually is used to join to the result set from 2 tables. Like the union is like to join like the column into 1 column, right? But the union and intersect and minus, like they will have the same number of column. Like maybe you can do something like this. But no matter how many columns you have, let's just randomly select something. So now you have each result set have 2 columns, right? And after you select it, you still have 2 columns. So you just like put this 2 column on the top of another 2 columns, like concatenate them together. But the join is another thing. Like the join is like you have a table A with maybe any number of columns, maybe m columns, and you have a table B have n columns, and after you join them together, the result set will have a column number of m mod m plus n column. So it's like you put these 2 tables side by side and join them together. But this is the union intersect and minus is more like put 1 column on top of another column. It's like vertical, and this join is more like a horizontal things. So let me give you a example, like maybe left join 2 tables. One is the employee table, another is the department table, but those are both of the table are from the human resource database. So let me first select something from HR department or departments, I think. Yep, so this is the department table. So what we can do is we can join this department table with our employee table. So let's maybe, let me think. Can we just first select everything from like HR.employees join with HR.department. Let me see. Missing keywords. Let me check. Oh, maybe if we use the cross join, we can directly do that, but otherwise we need to provide the condition. Yeah. So because later let me further explain what is the difference between those 4 types of join. But yeah, let's first examine like the result set, the column it has. So first, maybe let me select from HR.employees. So you see it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it has 11 columns. And when you cross join with the HR department table, I remember this department table has departments. department tables have 4 columns, but I'm not sure whether this is the foreign key column in the department table, right? And also in the employee table, there is a foreign key column also called department ID. I'm not sure whether cross-join will merge these 2 columns into 1 column, but if not, then this should result in 15 columns, right? 11 plus 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah. You see, there's a duplicate department ID. So one should from the employees table, and this is the primary key table column from the departments table. So if you use join keywords, they just put like horizontally concatenate these 2 tables. And so this is basically what will look like, the result will look like after you join 2 tables. And let me further introduce the difference between the left, right, and full and cross join. So actually, if you just use the join, it should be a full join, I believe. And therefore, you have to provide some condition like on HR dot, maybe I should put like this is the employee and this is the department. Let's join them where the department ID is equal. So department ID. So this keywords, you see, is the alias name of the table. So this means the department ID is from the employees table, and here the department ID is from the departments table. And further run it, you see, now we only join these 2 rows where they have the same department ID. And if we use the cross join, you will see that, let me borrow this. So if you use the cross join, you will see that no matter the department ID is equal or not, they just cross join them together, because cross join do not need any condition. So what does cross join do is like, suppose we have table A with rows 1, rows 2, and rows 3, right? And we have another table called table B. In this case, the table A is the employees table and B is the department table, right? And you might have same ID or different ID like this. But cross join, it doesn't care whether you have the it doesn't care any like conditions. It just join this to try all the combination to join different rows. For example, if you cross join A and B, it will give you something like join this row in the table A with every possible combination with the rows in the table B. So the result will be 1 concatenate with 1. So this, maybe I use the concatenate. So with 1, and also, so I think maybe I just read like this, as long as you get my idea. Like the result will be 1 and 4. So this is 1 triiver combination with the rows in the table B, 1 with 1, 1 with 4, and also 2 with 1, and 2 with 4, and also 3 with 1, 3 with 4. So you see, just cross join every combination, cross join every rows, and try out all the combinations. This is the cross join. But what is different between the full join is that if you use the A full join with B, you have to provide some condition like on like where the department ID is equal or not. So maybe the ID. So you will full join on this condition. So then what will be the result? When you use the full join, it will try to first, if they are have the same, they met on this requirement, they have the same department ID, then you will join these two rows together, like 1 and 1, like all the other columns within this row will be just concatenated to each other like this. No, let me run this. You see, based on this department ID condition, all the rows information, all those columns are joined together to each other. And but suppose you see there is some unmatch. If this unmatched things happened, then if you use full join, you should use the null value to fulfill the unmatched part. So you see, this department 2 maybe do not have any corresponding mass information in the table B. You will just leave a null value there. And then for the 3 is the same. If there is nothing, just leave a null. And here you see there is a 4, maybe a department with ID 4 and do not have corresponding in the table A, and you will leave a null value in A and write a 4 here. So this will be the result if you use the full join. So the full join is remaining all the rows in each of the table, and if there is no corresponding information, just fill the like the corresponding part with the null value, and but you will still maintain all the information in each two tables. But if you use the left join, things will little bit have a difference between when you use the full join. Like if you use the left join, it will only maintain all the rows in the left table. But if there is some like this 4 uniquely in the table B, it will be just get rid of, and only those rows corresponding with the table A will be maintained. So for example, if we use A left join with B, in this example, what will happen is first, the 1, 2, 3 in the table A will be maintained because it's a left join. It will maintain all the things in the left table. And so this 1 is the corresponding rows in the table B. So when you join them together, the result set should have a corresponding rows. So you can join this corresponding rows from table A and from table B. But for the column 2, the rows with maybe ID 2, it does not have any corresponding information in table B. So you just fill a null value with the corresponding columns. And also for the 3 is the same. There's no corresponding part, so just leave a null value. And you do not have to care about 4 because 4 is in the B table, and you just need to maintain all the rows in the table A and also fill the corresponding rows in the table B. And but if we use A right join with B, since it's kind of opposite, you will maintain all the rows in the table B in the right table, but but you will fill the uncorresponding part in the A with a null value, and also if there is some rows that in table A but table B do not have it, you just get rid of it, just like the previous example. If you have something uniquely in the table B but not in the table A, when you use left join, you just get rid of those unique rows that contains in the table B. So here, for example, let's first maintain all the things in the table B, like this 1 and 4, right? And also you would check when you try to fill the left part, you will see there is corresponding 1, but there is nothing corresponding as to 4, so you just fill it with a null value. Let's try to run some left join to see the results. Let me borrow this. Let's see. Maybe left join. So I used left join. Let me check. Invalid statement. Oh, okay. Let's see that if you use the left join, then that means all of the records in the left table should be maintained. So there should be some null value be filled in the right part. So for example, maybe we can count at first count asterisk, so we can know how many columns are there inside this result set. How many rows? Sorry, how many rows in this result set? So 107. So also it should be, remember that yesterday we have already count the number of how many rows in the employee tables, right? Employee. 107. So it maintains all the rows in the left table. And if you try to select some, maybe select some columns just in the table B, I think it should give you some null value. So maybe let me try to select the department. Maybe just select the department ID. Count department ID. Yeah, I should specify that this department ID should from the table departments, because both of the tables have the columns name department ID. So here, let me run it. You see 106, because you remember that the count, when you count on specific columns, it will get rid of the null values, right? So there should be one null values that field in the table B, because we are using the left join. But if we use the right join, I think first, if you just select it, you will see that the rows, the number of rows will be reduced to the number of the right table. So 122. So let me also select maybe, let's see how many rows does this department's table contains. It should be 120. No, no. Let me see what happened here. HR the employee, the right join departments. Select count. Why was it? That's kind of weird. Let me see the result set first. The department ID. Oh, there is a lot of duplicate department ID here. So maybe the rules of this is like suppose you have multiple like multiple employee from the department 1, and but you only have one. This is department table. You only have one department with ID of 1, and when you right join it, you see there is multiple match. So you will just maintain all of those matched rows. Like for example, the result set should be, if you right join with it, you should like this. So this will give you more rows than the original table B. Yeah, I think, sorry for the mistake. I think I should carefully review the rules of the right join. So, but the idea should be the same, that if there are some, like if table A have some department that's not matched with the this rows in the table B, then it should be get rid of, because this is why we call it right join. We only want to maintain all the things in right table. But if you use right join, there are some like something if happen like this, you have a department table, a department ID with 3, but it's not in the department table, then you should get rid of it. Or let me check if there is some employee that without a department ID, then absolutely should be get rid of when you use the right join. Let me check. Select asterisk from HR.employees where maybe department ID should equals to is equals to null or something like this. No data found. I'm not sure the syntax for the null ID. Maybe briefly Google it, like the null in the SQL. Oh, should use is now. Let me try to run it. Here, you see this Kimberly, this like the last name with Grant, with employee ID 178. It has the department ID of null. So if you use the right join like this, when you try to select where the employee ID equals to 178, it should returns you no data found. So this is the right join, because you see this employee in the left table, it does not have a department ID. So when you right join with the HR.department, it's like the unique rows that only contains in the left table. So it will be get rid of. But if you use the left join, then that means all of the rows in the all of the columns, no, not column, all of the rows, those data records should be maintained, because it's left join. All the things in left table should be maintained. And when you run it again, you can see the employee ID with 178, and the rest of the parts from this 5 columns these 4 columns derived from the right table that of department table should be filled with null value. So this is the difference between the left join and right join, and also the full join and cross join. So any questions related to the drawing part? Mm, is only equal condition apply is only equal condition apply uh, applicable in labs and drawing. So you mean you want to use some unequal, and then I think because it only allows you to use the on keywords when you use the join. So I think that means you only join these 2 tables like when something oh, and if I change this, maybe yeah, that's a good question. Like if I um, modify it to maybe not equal, is there any let me check, because I am not very familiar with those syntax. Like, oh, that's a good point. Maybe larger than or things like this. I think it's feasible. Like whenever this statement is whenever this condition be met, you can join these 2 tables together. Like so here you see all of the these 2 tables are joined on a condition like where the department ID larger than the department ID in the department table. So yeah, these 2 rows and these 2 rows. But how many rows will derive from this? I think then is that all of the combinations that who met this criteria, like the requirements, should be placed in, should be remained in the result set. Yeah. So it's possible to use other conditions, like just based on your like design. What if you use left join? I think that doesn't matter. Like for the left join here, you just change it to greater, because I think the syntax is just because the join doesn't have much difference between each other, just the rules. Like the left join is just maintain at least the rows should be in the left table, and if something unique, it doesn't matter what conditions you give to it. So you see, if you give another condition, it just follows your condition or giving, and to apply it on the join. So, but the idea is still the same. When you use the left join, you should, if some maybe some resulting rows that contains the left table does not have those information, then it should be get rid of it. Just like the previous example for the right join, like the left join and the right join is kind of symmetric, right? Just if you place this table, department table, from if you switch this two together, if you switch these 2 tables, the position in the SQL query, then it will change to a right join, right? Just the left join and right join kind of symmetric. Just maintain the things. If you use left join, maintain all the things in left table. If you join right join, maintain all the things in right table. But suppose you just switch them together, then it's become like the HR the employee right join with HR the department. Right? So I think this is for the drawing parts. And any other questions? Yeah, no problem. And let me check. If no other questions, then there's one thing that I want to introduce. That is called grouping by. So the grouping by is more uh, commonly seen with the aggregation function. That you see the aggregation function is more like you group a bunch of rows and then result in some result, like you group a bunch of records and return the maximum amount among it or the average of it or the mean of it. So if you use grouping by, it's more likely you can group by. So it's more likely you're using it with the aggregation function. So for example, if you aggregate the group a bunch of employees based on their department ID, like you group all the employees with the same department ID, and then you can count how many employees are there inside this department, right? So you can use the aggregation function along with the grouping by, like you can count employee, maybe employee ID, and also the department ID from HR the employee. And if want to group them by the department ID. Department ID. There is no typo. And also can run it. Department, I think. DEPAR. There is missing T here. Yep. So you see, this statement is like you group a bunch of the employees in the employee table based on the department ID. And also, because you group them with the department ID, so there will be a lot of employee with the same department ID of 50, right? And you can count the number of the employees inside that group. So you count on some columns, maybe the employee ID columns, and then this can give you like how many employees inside this group with the same department ID. And also, if you want to filtering it with some condition, then here you cannot use the where clause. You should use the having. So for example, having counts of employee ID greater than 30. So it only gives you the department that with more than 30 employees. But if you trying to use where, it should give you error because you cannot use where here. You must use the having when using the group by. So this is the group by statement. So any questions related to this part? So this is like you can use this to count how many employees inside each department. So you group them based on some condition, like group them based on the department ID, and then you can further apply the aggregation function inside each group. So it's like this. So if you have any questions, you can ask me during the break. So let's take 10 minutes break from now, and let's meet at 11. And if you have any questions, just feel free to ask me during the break.